Okay, in this video, we're going to go ahead and do number 5 from the exam. We'll do both parts, hopefully in one shot. Well, not one shot, but in one video. So here we're looking for this is a differential equation, but what we're really looking for is a function, in this case y, that meets the following conditions. The derivative's got to be 1 over t squared to the natural log of t, and when you plug in 1, you should get 3. So let's start with the first part. The derivative of y should be 1 over t natural log of t. So since we want to go backwards, going backwards means let's take the antiderivative. And now we can use the symbol. Now that you know that this symbol means antiderivative, if you want to, you can use that symbol. And notice that here you would set, hopefully you notice that u is ln of t and du is 1 over t dt. Somehow what happened is that I saw here the inside the natural log of t, I saw that part, but I also saw that its derivative, 1 over t, was right here. And of course the dt right there. And so now when I do this antiderivative, well, first u substitution, I'm going to go 1 over square root of u du. And what's going on here is that I replace the natural log of t with u, but I also replace the 1 over t dt, or the 1 over t dt, with du, so that's where that's coming from. And then I'm going to put a 1 in the numerator just to make sure we're okay. Now the next part is actually just algebra. This is 1 over u to the 1/2 du, but that is just the antiderivative of u to the negative 1/2 du. And so now here's the power rule. I add 1, and then I divide by that number. Negative 1/2 plus 1 is 1/2. Then I don't forget my plus c. This is an indefinite integral, meaning there's no domain. So here we get 2 u to the 1/2 plus c, but now I'm going to have to replace that u with my substitution. So that's going to be the square root of ln of t plus c. So that's what y is. So we found the n antiderivative. Now we got to meet the second condition. Y of 1 is 3. So now I'm going to move that up over here. And I'm going to go ahead and use that. So since y of 1 is 3, so what that means is that this expression, when you plug in 1, 2 square root of natural log of 1 plus c is supposed to be 3. But the natural log of 1 is 0. And of course, 2 times 0 is 0. So c is 3. So the answer that I'm looking for is y equals 2 square root of natural log of t plus 3. That would be the full credit for this differential equation. So let me see. There's other things that you can learn here, of course. U substitution, definitely use the power rule. And of course, the basic DC5, solving the basic differential equation. So that's part A. Part B, I want a function whose derivative, I want a function p whose derivative is 2 over 3 minus t. And when you plug in 2, you're going to get -5. Oh, one last thing. Notice about the previous problem. Sorry, I just realized that that here, if you think about it, y is equal to 2 ln of t to the 1/2 plus 3. Notice first of all that when you plug in 0, you do get, sorry, when you plug in 1, you do get 3. So that's satisfied because natural log of 1 is 0. But when you take the derivative, you get 2 times 1/2 ln of t to the minus 1/2 times 1 over t plus 0. And when you do all the algebra here, you get 1 over t radical t, which is what that's what you wanted. You wanted the derivative to be that. I took the derivative and I got exactly what I wanted. Okay, back to this one. Here, again, you want to know what p is. You want a function whose derivative is 2 over 3 minus t. So I'm going to go ahead and say, well, p then, I want to go backwards. So I'm going to take the antiderivative of 2 over 3 minus t dt. Here, I'm going to let u be 3 minus t because du is negative dt. And notice, what I notice here again is that there's a dt, and so I'm just going to multiply both sides by a negative, and now I'm basically ready to go. So it's going to be 2 over u, because I had 3 minus t, but I let that be u, so u is there. And then that dt that I was talking about earlier, dt is going to be negative du, so I can replace this with negative du, so there's my replacement. And now I'm going to take out that negative 2, be left with 1 over u du. And again, this is an antiderivative we've seen already in one of the videos, natural log of u plus c. And again, because this is an indefinite integral, we're going to plug in the value of u this time. So there is the function, but I need to incorporate this p of 2 is equal to negative 5. So p of 2 is equal to negative 5. So that means negative 2 natural log of 3 minus 2 plus c is negative 5. This is negative 2 times the natural log of 1, which is 0. And then you get c is negative 5. So the complete answer is going to be, I want p of t to be negative 2 natural log of 3 minus t minus 5. Notice that when you take the derivative, you get negative 2 over 3 minus t times negative 1 plus 0, which is just 2 over 3 minus t, which is what we wanted to show. Okay. Oh, and moreover, when you plug in 2, you get negative 2 natural log of 3 minus 2 minus 5. But then here, this is negative 2 times 0 minus 5, or just negative 5. So it's good. Okay. That's it for right now. I'll see you soon.